Hello everyone, welcome. And in today's lecture, I thought we'll do a very interesting problem called the three prisoner problem. And since I have discussed conditional probability with you just in the last lecture, this is the right time to introduce this particular question to you. This is a very interesting problem, and it is sometimes also called a paradox because what you think is not actually the answer to this. So I'll talk about both the cases. Like, I'll start with what is actually wrong and what you would actually think. Okay, that's the answer. But let's just dive into the question, and you'll know what I'm trying to say. So I've added a visual in front of you. There are three prisoners, okay, and let's name the prisoners A, B, and C, and all the three prisoners are on death row. So the governor decides that he wants to pardon one of the three, and he chooses at random a prisoner to pardon. So here you can say that maybe he'll put like three chits of prisoner A, B, and C, and he'll just choose one at random, and that is the person he has decided to pardon. And he has also told the warden that this one is being pardoned, and you are not supposed to tell it, obviously, because yeah, it is something that has to be kept secret till the actual thing happens. So but still, obviously, since you know that you're going to die, and there is a chance that you may be pardoned, uh, all the three prisoners would try to get to know who is being pardoned. So prisoner A had an idea. He told the warden that, okay, don't tell me if I am being executed or not, but just let me know the identity of one of the two who are being executed. So one will be pardoned and two will be executed. So he's saying that out of B and C, just tell me who is being executed. You don't need to tell me anything about me. And so the warden tells him, okay, B is being executed. Now, this information is some new information we got, right? And now my question is, what are the changes in the probability of A and C's survival or them being pardoned with this new piece of information? So if I write it down mathematically, what is the probability that A will be pardoned given warden has said that B will be executed, and what is the probability that C will be pardoned given the warden has said that B will be executed? So let's set the premise a bit. So we have three prisoners, right? A, B, and C. Okay, and one will be chosen at random. So until and unless you don't, in the beginning, I know that as a prisoner, my chances of survival are 1/3 and my chances of death are 2/3, and that's same for all the three prisoners. Okay. Now, if I say what is the probability that A survives given B dies? Okay, let's calculate that. So this is probability that A survives and B dies divided by probability B dies. Okay. Now, what are the different cases? So either A can be pardoned or B can be pardoned or C can be pardoned, and in that case, BC will be killed, AC will be killed, and AB will be killed, right? So these are the three cases that can happen. Now, what is the probability that B will die? So these are the two cases where B will die. So that is 2/3. Now, what is the probability that A survives and B dies? So that is just this one case where B will also die and A will also survive. And now, since the prisoner A knows that, okay, B is going to die, so that makes me my chance of probability B dying and me surviving as this case. So that is 1 by 3. And if I do the math, I get 1 by 2. So earlier the chances of survival for A was 1 by 3. And with this new information, he's happy that his chances of survival has increased to 1 by 2. Now, do you think this is correct? And the answer is no. This is wrong. Let's go to why this is wrong. And now I did not mention or put much focus on what I'm asking here, right? If you look at the probabilities that are being asked, the probability is, the information is that warden has said that B will be executed. It's not that I'm not asking that probability A will survive given B dies. I'm asking what is the probability A will survive given that the warden had said A that B will be executed. So in the denominator, the probability won't be P dies. The probability would be in what cases will the warden say that B dies. Okay. To prisoner A. Now, what choices does the warden have, right? If the warden knows that A will survive, that means B and C both will be executed, right? If warden knows that uh, B will die, then C and A will survive. Sorry, not die. B will survive, then C and A will die. And if C will survive, then A and B will die. Okay, but the warden can't give any information about A. Prisoner A has asked the warden that you just tell me everything that you know about B and C. You just tell me out of B and C who will be executed. Now suppose, let's do the easy cases. Now suppose the warden knows that C is dying, that C is surviving. Okay, then in that case he can only say that B will die. Okay, and the probability of that happening, the probability of each of these happening is 1 by 3. The probability of that happening is 1 by 3. Okay, second case is if B is actually surviving. Okay, in that case the warden cannot say that B is dying. Okay, so the probability of that is 0. And the third case is that A is surviving. So B and C both are getting executed. So the warden can just randomly decide to either say B or say C. So, and the chance of this happening is 1 by 3. And out of this, probability of choosing these two is half and half. He can choose any one he wants to say. So the total probability is actually 1 by 6. So the probability that in this case the warden will say that B dies is 1 by 6. So I'll just go through this again. So what did prisoner A say? Prisoner A said that you don't need to give any information about me, but one out of B and C will be executed for sure, right? Regardless of what happens to me. So you just tell me the name who will be executed, and the warden knows who will be saved and who will be executed. If the person dying is C, then he can easily say B. Okay, so the probability of that happening is 1 by 3. If actually B is dying, then the warden can't say B is dying. So the probability of that happening, that warden saying that B is dying in this case, is 0. And if A is surviving, in that case the warden can say either B or C. And out of that, what is the chance that the warden will say B will die? So that is, it can be randomly chosen. So that is half. And half of 1 by 3, because the chance of this actually happening is 1 by 3. So this is the probability that will come below. So what is this? So this is 6, 2 plus 1, which is 3 by 6. Sorry, so this is half. Okay, and in the top, probability A survives and warden says B dies. So the cases are in front of you, right? There is only one case in which when the warden says that B will die, uh, is where A survives, which is this case, right? The probability of that happening, we have seen, it's 1 by 6. So now my total probability, the conditional probability which I had asked above, is actually 1 by 6 divided by 1 by 2, which is 1 by 6 into 2, which is 1 by 3. And sadly, if you see, there is no change in the probability of A surviving, right? So yeah, that's just sad news for A. But let's look at what is the probability of C surviving. Okay. Given warden has said that B has died. Now, okay, denominator, there is no change. It's just probability of warden saying that B will die. But what is the probability that C survives and warden says B dies? And that is this case. Okay. And now since here the probability is 1 by 3 and not 1 by 6, it's just 1 by 3, right? Because if C is surviving, then the warden will just say B. There's no other option. But in case A was surviving, the warden was making a choice between B and C. But here, the warden is just knows that C is surviving and he tells B. And the chance of that is 1 by 3. So on the top, we have 1 by 3. And this is 2 by 3. So actually the probability of C surviving has increased with this new information, but the probability of A is still the same. So you would think that this is a very easy problem when you just read it, right? And you'll calculate the wrong probabilities. And this is what A also must have thought and been happy that, oh, my chances of survival has increased. But you have to be very sure of what is being asked. It is not that it's not probability of A surviving given B is dying. It's the probability of A surviving given warden has said B is dying. And what are the cases in which warden will say B is dying, right? That probability is different from probability of B dying. And that changes the whole equation of the question. So it's very important to look at the detail of the question being asked before you actually calculate the probabilities. It may look very similar, it may look one and the same thing, but keep this in mind that what is being asked. Don't miss any detail when you're asked these type of questions. The result is in front of you. And so yeah, I would like to conclude my lecture here. I hope you guys enjoyed it and I hope you understood this problem. There are multiple problems with a similar premise. I have covered one. I'll add in the description the different problems which you can go through which have a similar paradox. And I hope you understood it now thoroughly, and thanks for watching. Let me know if you have any feedback. I'll see you next time.